well, good morning, everyone, and welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? I missed you guys, too. Merry Christmas. Happy New Year to y'all. Yeah, I was, the first week that I was, away, I was thinking, I wonder what they're doing. No. I actually totally unplugged, guys. I left all electronic devices on the side, believe it or not. Some of you are like, what? You weren't touching your phone? No. Completely unplugged. Didn't shave for about a week. I was all scruffy looking. I started talking gibberish and anyways. But yeah, it was a good break. Good break. Good to see y'all. But like always, last semester we started with a lesson and then I left you home play. Well, guess today? Lesson and home play. Let's go! Semester 2, we got this. Once you're done with warm-up number 63 that's on the screen, go get yourself a graphing paper because we're going to continue with transformation. Huh, Martin? Let's go, Martin. You got this. All right? I'll give you some time. Copy and just show on the road. Being that it's the first day back, here it goes. I'm going to go over the entire warm-up just to make sure you get all those tamales out of your noodles. I know some of you are slowing down with all that excess food that you guys had over the break. Tri-tip, carne asada, ribs, tamales, and tamales, and tamales. Oh my goodness. Everywhere I went, it was like tamales, my goodness. All right, here we go. Number 1, it reads, complete the square and factor. In case you forgot, to complete the square, we need to add one more term. What do we add? Well, we take the coefficient of the second term divided by 2, and then whatever that is, you square it. So we end up with x squared plus 14x plus, what is 14 divided by 2? 7 squared is 49. So we're done with the first part, which is called what? Completing the square. Second part, we need to factor. 49 goes up here, 14 goes down here. So what two numbers multiplied give me 49 that when you add them give us 14? 7 and 7. So we would write x plus 7 and x plus 7. Or in other words, another way of writing it is x plus 7 what? Squared. That's why this is called completing the square. Ooh. You're like, Mr. Q, I remember these. Oh, yes. This is our bread and butter. Let's go. Number 2. Let's see. Share with your neighbor what you got for part A. See if they remember. What is part A? Who got 3i? 3i. That is correct. Once again, how do we break that down? Square root of -1 times square root of 9. What is square root of -1? There's no such thing. That's why we call it I for imaginary. Ah! Square root of square root of 9 is 3, and that's how we get 3i. 2b. We have a fraction with the denominator being a square root. We can't have a square root on the denominator, so we multiply top and bottom times that denominator. So square root of 7, square root of 7, top and bottom. So we end up with 5 square root of 7 over, what is 7 times 7? That's 49, so we write square root of 49. Therefore, the numerator stays the same, 5 square root of 7. What is square root of 49? 7, and that is our final result. That's how you get rid of the square root on the denominator. And last but not least, this one, we need to find the decimal. So, let's think, between what two perfect square numbers do we find 70? Oh, it's in between 64 and, that's 8 times 8. 9 times 9 is 81. 70 fits in between those two numbers, yes? So the smallest number is 64. which means square root of 64 is 8. So 70, square root of 70 is going to be 8 point something. So how do we find that something? Well, here we go again. The middle minus the small, so that gives us 6 over the large minus the small. 81 minus 64, that's what? 17. Therefore, long division, 6 divided by 17 does not fit. Add a 0, decimal. 7 fits in there 3 times, yes? Yes, 3 times 17 is 51. Subtract that's 9, add another 0. And that one would be, is it 5? 17 times 5, yes? Yes, Mr. Q. All right. And that's a 5. So this would be 8.35. Somebody got something like that? Yes? Without using a calculator? All right, good. You guys okay? Yeah? Is your brain trying to process already, like jumping straight into where we left off? Yeah? All right, good. Maybe you had a family math night during the break? No? That would have been, you would have been the popular one, right? It says factor by grouping. All right, so let's get started. 18 and 9. What two numbers multiply give me 18 that when you add them give us 9? Tell your neighbor. Two numbers multiply give us 18. When you add them give us 9. Martin, go. 3 and 6. So since they want us to do grouping, we can't go straight to just get our factors with a shortcut. That's when we do what? Bring down the first term, bring down the last term, and instead of writing, look up, instead of writing the 9x, what do I write? 3x and 6x. Oh, 3x and 6x. So now we can group. First two, second two. So GCF for these two, x, we're left with x plus 3. GCF for these two is 6. We're left with x plus 3. What's the same here and here? X plus 3. What's left over? X plus 6. Ooh-wee. These are my factors. Is it coming back from the final we had last semester? Yeah? You're like, yes, Mr. Q, bring it. Second semester, let's go. You good? Yes? All right. And once again, try to give a plug for people that are in Algebra 1, Algebra 2, or statistics from your peeps, cousins that you saw over the break or something. Tell them that I have a YouTube channel. Get some more subs in there, yeah? Let's go. I already have about 1,100 already. Let's go. I'm going to start getting paid once I get like 1 million. Anyways, actually I don't monetize, so it is what it is. Here we go. Last one. Find the inverse of this. So what is the first thing we do? Change it to y. Negative 3x plus 6. Then we solve for x. So that means we subtract 6, y minus 6 equals negative 3x. Divide by negative 3, divide by negative 3, and we're left with y minus 6 over negative 3 equals x. Is that the inverse? No. Tell your neighbor what to do from there to get the inverse. What do we do from there? We switch the variables. All right, switch the variables, so we end up with x minus 6 over negative 3 equals y. Can we leave it in y form? No, we need to change it back to what? F of x. But, check this out. Since this is an inverse, we need to indicate it by putting the negative 1 right there. All right? We good? Andrew, you good? All right, good. So attentive, everybody. Man, I can feel the power, the brain power coming. All right. Copy the agenda, please. Here we go. Agenda for today, warm-up number 63, transformation of functions. And tonight's home play is only 5 transformations. Only. Once again, you will need a graphing paper if you haven't gotten one. Also, get a Cornell note ready. Let's see. Yes, get a Cornell note ready. Warm-up 63, transformation of functions, and 5 transformations for your home play. All right, I'll give you guys some time to get your graph paper in front of you and also your Cornell note. You don't need a fair model started. Actually, yeah, let's get a fair model started. Yeah. Your home play for tonight. Look up. Do me a favor, get your phones out. Take a picture of that. If not, you can go to YouTube and look at the video lesson that I'm going to upload today. But that's the home plate for today. I couldn't get a Nearpod code. I was going to give you guys a Nearpod code, but for today, there it is. I'm allowing you to use your cell phones. Ooh. Not that you use them or have them under your desk, right? Anthony, D, right, and E. Oh, okay. All right. We got it? All right, put them away, please. So with that said, our objective for today can transform a function using different parameters. I can transform a function using parameters. Today's going to be more like a review of what we did, but I just want to solidize one more parameter that we used. And I said get a Freyer model. Everybody got a Freyer model going? Yes? All right, good. So I can transform a function. So let's think. Get those brain waves going. Get all the tamales, scoot them out the way. What is a function? Without looking at your notes, tell your neighbor what a function is. What is a function? What is a function? Some of you are like, oh snap, I forgot. No, you didn't. Ah! All right, in your own words, without looking at your notes, give me a definition on that Freyer model that you wrote in. A definition for function. What is a function? Function. Looks like Jacob's got it. Very good, Jacob. All right. I see Don's got it. I see him like really focused. Martin, of course, he's got it. All right. Brandon's got it. All right. Function. Let's see, in your own words, what is a function? Anthony, D. Equation that has an exact input for every output, vice versa. I'll take that. Here it is. Yeah. So instead of an equation, it's a relation. A relation. Just to bring us back. So make sure you write that down one more time. For the examples, just write the relation here inside the brackets. You don't have to write the forms because we already know the forms. And then the non-example, hashtags. Use some time. So copy this down on your Cornell notes. It says, let's generalize the rule. If you combine all that we did so far, we get g of x equals a times f of x minus h plus k. We're going to break it down to make sure that we know exactly what each component does. And of course, we're going to start with k. Tell your neighbor what k would do to any function. What does k do to any function? See if they remember. Yeah, up and down. So k goes up if it's a positive number going in there, or down if we substitute a negative number in for k. So let's go with H. 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 What does H do, everyone? Side to side, that is correct. If we substitute a value in here, which is a positive, it takes us to the right. And to the left, it's going to go with a what? Negative. That is correct. Just remember that, because this is where some of you struggled on some of the transformations. Whenever we substitute a negative in here, then all of a sudden this turns into a positive, right? And here's a third one that we kind of touched into, but we never really solidized it. But here it goes. Parameter A. Parameter A either stretches or compresses. Stretches if it's a whole number, or compresses if it's a what? Let me repeat that again. It stretches if it's a whole number instead of A. If it's a whole number, it stretches the function. When will it compress it? When will it compress it? When it's a what? Decimal or fraction. That is correct. Decimal or fraction, it compresses. So to see it, stretches, it's going to look like this. Compresses, it's going to look like this. Small. Okay? And of course, we already know that whether it goes left or right and so on and so forth. All right. So with that said, shall we get started? Get your graph paper in front of you. Let's start with a big graph paper. Example cube. Write that at the top left, please. And it reads, graph f of x equals x squared, given that g of x equals a times f of x minus h plus k. And then it says, write the new transformed function when a equals 2, h equals 4, and k equals negative 5. And then we will graph the transformation. So copy that at the top left of your graph paper. Then we'll do that together. All right, here we go. It reads, graph f of x equals x squared. We're going to graph this now without a table. Here it goes. Y'all ready? Look up to the screen. So last semester we started with tables and such, which was good. But now we're going to go a little bit faster. Here it goes. Start with an x value. What x values do we use for any graph? Tell your neighbor, what x values do we use for any graph? I told you that last semester. For anything that we graph, we were going to use which x values? Which x values do we use? Anthony, E. Which x values? -2, -1, 0, 1, and 2. So this is how you graph without a table. Here we go. We start with -2 of x. -2. According to that function, what do we do to -2? We square it. So what is -2 squared? -2 squared is 4. So that goes -2, 4. Next value, -1. What is -1 squared? 1. 0 squared. 0 squared is 0. 1 squared is 1. And 2 squared is 4. Bless you. And we're going to label that f of x. Is it coming back? Yes? Yes, Mrs. Q, we love these. All right, good. All right. So we got that part 1 done. But then they say, write a new transform function given these. So here we go. Here's how you do the next part. You write your form. There it is. But instead of A, what goes there? Instead of H, and instead of K, therefore my new function is g of x equals 2 times f of x minus 4. And then K is -5. However, what kind of function is this, everyone? It's a quadratic, so we need to write the little squared right there. Don't forget that. Some of you got docked a point on your final because of that. So, what do we do first? Well, first we start with labeling where it's going, where are we going to move this? Where will it go, everyone? 5 what? 5 down, so put an arrow, 5 down. And this 4 is going to take us where, Jacob? 4 to the, yeah, he said right. That is correct. So now that we know where it's going to go at the end, we need to focus on this one. Look up. On the 2. And if it's a whole number, it's going to do what to the entire function? Stretch it. If it was a fraction or a decimal, it would go what? Compress it. So in this case, it's going to stretch it. So how do we stretch it, Mr. Q? Well, look, I'm going to take this. Look up. I want you to highlight the y values of these points. What is the y value here? 4. So therefore, what is 2 times 4? 2 times 4 is what? 8. So these 2 points, I'm going to move them up to 8. Now let's go to the other y value for the other 2 points. What is the y value here, guys? 1. Is that correct? So what is 2 times 1? 2. So I'm going to move these 2 points up to 2. And 0 stays at 0. So let's graph that and see if it stretched it. Does it look like it stretched it? Yes, it did. Kind of like made it a little bit skinnier and stretched it up, yes. Lower that a little bit. I'm going to lower the music in the back just because the copyright, sometimes it mutes my video, so FYI. All right, so now that we stretched it, we're going to move this one, this red one. Now we're going to move it in which direction, guys? 4 to the right and 5 down. So I'm going to start here. 4 to the right. 1, 2, 3, 4, and 5 down. 1, 2, 3, 4. This one. 1, 2, 3, 4, 5 down. 1, 2, 3, 4. Oh, I needed to move this one more down. Sorry. All right. This one right here. 4 to the right, 5 down. 1, 2, 3, 4, 5 down. 1, 2, 3, 4, 5. This one. 1, 2, 3, 4. 1, 2, 3, 4, 5. And 0, 0, 4 to the right. 1, 2, 3, 4. 1, 2, 3, 4, 5. So my end transformation, now that I stretched it and everything, is right here. And that's the one we're going to label g of x. So let's go over the process. First, we started with f of x equals x squared. Do we know how to graph that without a table? Yes. Next, we rewrite our original function given the parameters that they give us. If it's a quadratic, we write a squared there. And then we first start with the stretch after we know where we're going to move it. And then we move it at the end once we stretch it. Okay? From 1 to 5, how comfortable are you with this so far? Yeah. 4, 5. Okay? Is it coming back for some of us? Yes? Yes, Mr. Q. All right. That's pretty much the home plate. So before we leave, look up to the screen. Look at this one. On that same graph that you just did, you already have f of x equals x squared. Is that correct? Yes? So I want you to write me the new function given these parameters. Write it underneath the other one. See what you get in red. Write it out. Then we'll have Brandon share out, see what he got. Oh yeah, we got this. All right, share with your neighbor your new function. See if they have something similar to yours. All right, Brandon, Darty, go. 1/4 times f of x plus 5 plus 3. Very close. Tell your neighbor what's missing. The square. Don't forget the square. All right, we'll stop right there. Enjoy your home play, everyone. Reminder, tutoring after school. Be there or be elsewhere. Bye.